So hello everyone and welcome to the next lesson on EKGs, and this time we are doing the QRS axis. So as we continue down our general approach to the EKG, we are going to talk about QRS axis. And it's one of those topics that comes up every now and then that we should know about. But in truth, in the transport environment, the axis doesn't always make a great deal of change to our interpretation of the ECGs, but certainly something that's good to know about. So we're going to chat very briefly about a very straightforward technique to figure out whether your axis is normal, and to talk briefly about what an axis is. And then if you really want to join me going down the rabbit hole, we'll take you through basically how you actually calculate an axis and a bit of a deeper dive into that and some of the causes of left and right axis deviation. So first great question is, what are we talking about when we talk about the axis on the EKG? And what we are talking about is the QRS axis, which means we're looking at the QRS complex on the EKG, and we're really talking about the direction that the ventricles depolarize in. And if you look at this really finely drawn representation of the heart, the ventricles depolarize really from the top left to the bottom right of the page, and flows from the AV node and down through the ventricles. You'll note that this red arrow that you see on the screen is skewed a little bit towards the left ventricle. And that would be normal given that the left ventricle has more muscle mass than the right ventricle. So really what we're talking about is electrical current flowing down the ventricles, and it's going to skew a little bit left just because of the way the heart sits and the mass of the ventricle on the left side. The use of an axis is really to say that if it's normal, we're happy that the heart looks electrically normal, is a little more likely to be structurally normal. And then if it's abnormal, we have to ask ourselves the question, well, what is causing that abnormality? So I suspect most of you have run across this technique, the double thumbs up sign, and it's just a really quick and dirty way to say, hey, is my axis normal? So if you look in lead 1 and lead AVF, if the QRS complex is mostly positive in both of those leads, double thumbs up, meaning your thumb is up, the QRS complex is up in lead 1. Your thumb is up, the QRS complex is mostly up in AVF. Double thumbs up, you're happy, you've got a normal looking axis. So if you want to keep it fairly simple, this next technique sort of works. It's not quite perfect, but it's close. So if you were to look at the up and down thumbs for 1 in AVF, if your thumb on your patient's left is pointing down, meaning lead AVF is mostly downwards, then you have left axis deviation. Left thumb is down, left axis deviation. Similarly, if you look at the ECG and your lead 1 is down, but AVF is up, then you have right axis deviation. So it's not perfect, but it's not a bad way to look at axis deviation on your EKG. So if you have a peek at the heart, remember we're talking about the QRS axis, meaning ventricular depolarization, so the direction of the QRS complex, and we want to look at the direction it goes in two separate planes. So in this case, we're going to look at it using lead 1, which of course goes from left to right, and lead AVF, which goes top to bottom. Now these concepts don't sound familiar to you. They are in the Introduction to EKGs and Electrocardiography, and certainly it's going to be helpful if you just review those. So really at this point, if you have understood the idea of what an axis is, and that the double thumbs up sign, if you look at lead 1 and AVF, is going to basically tell you if you have a normal axis, and then you have a bit of a cheater's way to think about left and right axis deviation, you could probably stop this lesson. Knowing that if you run into other things, you can look that up pretty rapidly. So happy at this point if you want to bail, have a coffee, move on to the next lesson. If you want to do some further math and go down the rabbit hole of really how do we work out an axis in its entirety, happy to take you there, and that's going to be the discussion for the next bit. And then right at the end, we're going to talk about the causes of axis deviation, although again, these are things that are probably best just looked up at the time. So the nice part about the QRS axis is that we can plot it out as a vector. And again, if this doesn't sound familiar to you and you want to know about it, there's a lesson on vectors early on in these lessons. But we are actually going to use lead 1 and lead AVF to plot out the vectors of the QRS complex. So what we're going to start to do is by looking at lead 1. And we're going to look at the QRS complex in lead 1. And we're going to ask the question, is it positive or is it negative? So we're going to look at that QRS complex and count the number of boxes high it is, positive, and the number of boxes that has a negative deflection on the QRS. So if you look at lead 1, the QRS is actually starts out in the positive direction and goes upwards for 7 boxes. And then right at the end of that QRS, it goes negative for about 2 boxes. So we're going to add those two together, positive 7 plus negative 2. It's going to give us 5 boxes. And basically on any kind of grid paper, you can just plot that out. So we're going to use 5 boxes on the grid paper you see here. And remember that if you're going in the positive direction, you are always heading towards the positive electrode. So in this case, we're going to go from screen left to screen right, heading towards the positive electrode for lead 1. So then we're going to look at lead AVF. And in this case, again, we're just going to count positive and negative boxes. And as you see, lead AVF is all positive. In fact, it's about 7 boxes high, all in the positive direction. And we're going to plot that again on our graph paper here. And in this case, remember that lead AVF, the positive electrode is downwards. And so in this case, we're going to plot 7 boxes downwards. And then because the QRS complex is actually an electrical vector, we can just draw the two ends together, and that's signified by this red line. So the red line here is actually your axis, and looks surprisingly like the drawing we had on the other page. And so if you look at what is a normal axis, and the red line that we had from our previous drawing is actually superimposed on here, you can see that for this EKG, we are well within the normal axis. And a normal axis really runs between negative 30 degrees and positive 90 degrees on here. So pretty happy that we got a normal axis at this point. Now, if you want to go down this super nerd rabbit hole, you can actually calculate that angle out. And I confess it has been a long time since I've done this sort of stuff. My mathematics surrounding triangles and angles, sines, cosines, and tangents is more than a bit rusty. So I had to actually make a little journey into the internet world of triangles. But here's basically the formula that you would use. It's the tangent formula for calculating that angle. And you can work it out in the way I've shown you there. And you find out that your angle is 54 degrees. And so if you have a peek at that, what you'll find is 54 degrees is well within that normal parameter between negative 30 and positive 90 degrees. So we know we got a normal axis. Okay, so at this point we have another ECG. And why don't you work out the axis? Feel free to pause the video using the spacebar or the pause button and take a moment to work out the axis, either by plotting it out or whatever quick and dirty method you want. And then we'll meet back on the other side of that pause and talk about the answer. So I went a little bit nerdy and drew this out on this case. But if we look at lead 1, so lead 1 is pretty much all positive. And it actually is 12 of the little spaces positive. May not show up quite as well on this video, but 12 little boxes positive. So we're going to go from screen left to right, the way lead 1 would be, 12 boxes positive. And then we're going to have a look at lead AVF. And notice lead AVF has about 1 box that goes in the positive direction right at the start of the QRS complex, and then 13 boxes negative. So we're going to add that negative 1 plus 13. That's going to give us 12 boxes. And that's going to move us in the negative direction. Remembering again that negative for lead AVF is upwards towards the top. So we're going to diagram it out as we see here. Connect the two ends of the vector, and that gives us our axis, which is represented by the red line. Now, if you do a little bit of that nerdy math, or you just know that, you know, if the triangle has the same sides, you've got a 45-degree angle there, that we know the angle, or the axis is actually negative 45 degrees. So if you look at our little diagram below, we actually know this is left axis deviation. If you were very fast and smart and did it the cheater's method, and you said that lead 1 is upright, so my thumb is upright, lead AVF is down, so my thumb is down, and then take that as though it's your patient, and their left thumb is down, so it's left axis deviation, you could pretty much make that a good judgment call. That technique, of course, fails a little bit sometimes, because you'll notice the normal axis isn't really 0. It goes up to negative 30 degrees. So sometimes you can get burnt with that technique. So that's why I would like to plot it out a bit, but that's the way to do it. All right, same thing. Why don't you pause your video recording and let's work out the axis here. So this time we have right axis deviation. So again, plotting out lead 1, we see that it is primarily negative. You have basically one box in the positive direction right at the start of the QRS complex, 3 boxes in the negative direction. So that's going to give us 2 boxes negative. So we plot that out on our graph paper. And in lead AVF, you've got 8 positive boxes and maybe 1 negative box right at the start of the QRS complex. I'm being maybe a little overzealous in calling that. But we'll say it's 7 positive boxes. So AVF, you're going to plot in a positive direction and connect the 2 with your red QRS complex line, and there's going to be your QRS axis. And you can see in that case, if you compare it to the chart right at the very bottom, that our axis is now in the negative, in the right axis deviation quadrant. So that sort of sums it up, how you work out an axis electrically. But the big question then becomes, well, what the heck do you do with it? So the truth of the matter is, I pretty much always go back to a list and look these up. On the top of my head, the things that I often think about is that you get right axis deviation if you have much more muscle mass on the right side, so right ventricular hypertrophy. You do get it if you have some of the pre-excitation syndromes that particularly come through the right ventricle because you're activating the right ventricle first. And you can have it in COPD, emphysema, and again, probably a bit more because of the buildup of the right side of the heart to overcome the resistance in the pulmonary circulation. And then a whole list of other goodies here. And again, you know, if you find right axis deviation, then often worth just looking it up. So similarly, I do the same for left axis deviation in that I go back to look it up. And I remember the same sort of things I do for right. If you got a big left ventricle, lots of muscle mass and hypertrophy, you may well have left axis deviation. You can see it some of the time in left bundle branch block, although not all the time. So it depends where that block is. And certainly you see it in the anterior fascicular block. And then you can see it in ventricular rhythms. You can see it if the diaphragm is up high and pushing on it and mechanically moving the heart out. And then a whole bunch of other that you can see here. So my take is, again, when looking at axis, I'm hoping to find a normal axis. If it's not normal, I'm trying to figure out right or left axis deviation, and then really just coming back to my list of causes, which I look up every time. Anyways, that is it for axis. If nothing else, I hope you understand the concept. I hope you have a really quick and dirty generalized way to say, hey, this is a normal axis. And then really, if for those things that aren't normal, you probably got time to look it up, to be honest with you. So if you've enjoyed going down the rabbit hole, that's fantastic and glad to have you with me. And if not, sorry to put you through it. And we will see you on the other side in the next video.